pleased to welcome the lead of process engineer, Chang. Is a very special guest from us, from Texas Instrument and the printed electronic community from US. The engineer Chang is a senior research scientist of material sciences. Chang is a specialist on polymeric characterization of printed electronics with his group in Texas Instrument. And today we will be sharing with us his expert opinion on semiconductor and printed electronics industry. With that, I ask to give full attention to Sean and help me to welcome to the stage. Please, Engineer Sean, welcome.
Thanks, Julie. Anyways, let me go ahead and share my presentation for today. In any case, thank you everyone for joining my TechBlick talk. My name is Chang, and I am working in Kilby Labs at Texas Instruments. Just a little bit of background about me before we get started. Kilby Labs is Texas Instruments' innovation lab. TI is a major semiconductor manufacturer that is very famous for their calculators. Kilby Labs is named for Jack Kilby, Nobel laureate, who invented the integrated circuit. They take on high risk, high reward projects. So naturally a good fit for printed electronics. But in any case, we'll go ahead and get started with my talk here. Let me see here. So before we really start delving deep into the details, I just want to take some time to really talk about what printed electronics really means here at TI. Now, if you end up looking here on my slide, at the very top, I've shown a very simplified and concise representation of a typical process that might be used in semiconductor manufacturing. Namely, this is a photolithography process. And if you go from left to right, you can imagine that you've got a photoresist coat step that is then exposed with a photomask to define these patterned features in your wafer. Once the exposed material has been developed out, then you can go through with your materials deposition method of choice, strip the resist away. And this is, again, in essence, very simplified how chips are made. Just going through these sort of processes over and over and over again until you can build up the sort of material stacks that you need to make a functional working chip. Alternatively, you could just print the thing. And here I have such a printer on the bottom left where you may be able to print certain materials on wafer that is shown prominently in the bottom right there. This is actually a wafer that has been received out of wafer front end fabrication. And this green material, for those of you who have very discerning eyes, you will be able to see that they're all actually patterned in a very particular way. Those of you who can resolve differences in micron scale will also notice that each of these three different sections on the wafer are actually different in thickness as well. So additive manufacturing, and namely inkjet, which is going to be primarily the focus of this talk today as an example of printed electronics. It offers a lot of flexibility that you don't really see in a lot of semiconductor manufacturing methods used today. And that's something that we'll delve in a little bit deep